Hi and welcome to this segment here where we're going to look at yet another example of using the fixed point to find the positive root of this equation here. So you can write this equation in the form, okay, if we write it in the form f of x equals to 0, we have this minus 1 equals to 0, okay? Then we remember we would like to now put it in the form x equals to maybe a function of x. So that way someone could have written that x e to the power x equals to 1, for which we have that x equals to 1 divided by e to the x, which is the same as saying e to the power negative x, okay? So next we would like to find the derivative, okay? So this is in the form x equals to phi of x, where this is this, okay? So we'd like to find the derivative of this, which is going to be, we are going to differentiate ex, okay? And then what do we get? We are going to get minus e minus x, which is going to give us e minus x, okay? And then we know that now we would like to check one. We know that all exponential functions are continuous, okay? This is from our calculus. Exponential functions are continuous. Next, yes, even on this interval. The next we would like to see or to check that is this less than 1 on the interval which was given to us 0, 1. Yes, it is not so, because this one here we know easily from the graph of ex, it is exponent, it is what is the word, asymptotic to the x-axis. This is x and this is the value here of e minus x, and this is 0, okay? And the value here is 1. So we know that it is less than 1 on the open interval for numbers between 0 and 1, okay? So we know that that is going to work for us. So the next thing, we are going to compute for xn plus 1 in that, okay? So in other words, we are going to compute, we are going to use this sequence here, xn plus 1 equals to e the power negative x, okay? So what do? We choose a root, okay? We choose an initial root between 0 and 1. Maybe we can say that x naught will, we can do the table first. We can write our n, then x naught, then xn, okay, then xn plus 1. What is xn plus 1? Xn plus 1 equals to e to the power minus xn, and then we can have the errors. So when n is 0, maybe you can fill this one here, you have 0, then here you have x1, which will equal something, and then here you have x1 minus, then here we would fill in the value x1 minus x naught, okay, the values you have here. And then when n is 1, what do we have here? We have x1, and then here we compute for x2, okay, because x2 is equals to e power negative x1, and then here we would compute x2 minus x1, and so on and so on, okay? You get it? Yes, when n is 2, we have x2, then we have x3, which you compute, okay, x3 equals to e minus x2, this is e minus x1, and then this is e minus x naught. Okay, the values you already have them here. Okay, yes, remember this is x1 here, so it will come here. This is x2, on the next step it will come here. This is x3, it is what will come here, and so on. 3 x3, then you get x4, then it will come here, and so on and so on. Okay, then here you keep on computing the errors until they satisfy the given tolerance, then we stop. That will be our termination criteria. Okay, yes, so this will just fill in this table here. You can do that using by hand. I hope the iterations are not so many. However, like I said, I don't like doing this because I make so many mistakes, but for us, we shall look around for problems. I'm not going to test. Okay, I'll look around for problems where I can test understanding and not so much, very long things where you're most likely going to make errors and so on, because in real life this is really not done using pen or hand and so on. So now I would just like to take you to the script which I wrote. As usual, I told you I wrote the script in a different language so that you can also have some work to do when it comes for your own MATLAB. I will let you know how you can do that. So again, we have the tolerance, then we can set our initial value. Because it is between 0 and 1, we can set it as that. So I state an error because I have to what is the term used? I have to define it, okay, because I am using it here. So and then we set a count, which will help us to know how many iterations we are going to need. Okay, so while the error is greater than the tolerance, of course the error is 1 here, is greater than the tolerance, so it will run at least the first time. So I have my xn plus 1 equals to e the power negative xn. So it is just x1 and then the x naught. This is xn plus 1 and then this is the xn. Then after I compute that, then I compute the error and then I set e because it will run the first time and then go. So when it is going back, I set my x naught to be the x1. Okay, yes, the x naught to be the x1. You get it, i.e. the xn to be the xn plus 1, the value which I got. Okay, then I use it to compute the next xn plus 1 and so on, and then I update the count, and then this is already seen from the previous video. So we are going to run it and then see what we get. I think what is the name? I keep on forget. No, not that. Here it is called fixed point. So we save fixed point 2. So we come here and then we run fixed point 2. Yes, and then when we run it, we see that it just converges in how many 14 iterations, and we have the root, which you can write to if I've told you maybe this number of decimal places or this number of significant figures and so on, then you can get the value here. Okay, so we will first write out just by hand maybe the first few, and then make sure that maybe you have the values, and then maybe you can see how we can run it also in MATLAB. Okay, so thank you so much and see you in the next video.